Now we are getting into organic compounds. So our first task is to learn about how to write organic structures. At this time, you should know how to write Lewis structures properly, how the shapes are determined for molecules. So all of that is your basis for going forward. Okay, so let's get started. All right, so let's look at the chemical formulas. Okay, so there are some chemical formulas you're already aware of, which are the empirical and the molecular formula, right? The empirical formula is the smallest ratio. Molecular formula is the actual ratio. Okay, you did this back in general chemistry. So then there are other formulas that we're going to go over, all right? So let's go over this one just to kind of get a review. So empirical formula is the smallest ratio of elements. Now in general chemistry, what happened was that the empirical formula was a lot of times also your molecular formula, not so in organic though, okay? Although this compound that I have chosen, this one is also a molecular formula, but what that means it exists as a compound, okay? You can find it or you can synthesize it, that's what that means. So, but in Gen Chem, a lot of the empirical formulas were also the molecular formulas because, yeah, those were the actual compounds like NaCl, right? Sodium chloride, that's empirical and also molecular. To get the molecular formula, which is the actual ratio of elements in any compound, you have to take the empirical formula and multiply it by an integer. How do you get this integer? Okay, you might remember that from Gen Chem also that you have to take the actual compound, whatever the compound is, you don't know what the mass is. So you have to find the mass of that compound and you use a mass spectrophotometer, an instrument, to find the mass of that compound. Once you have the mass of this compound, you take the ratio of these two and then you find the integer. Okay, so that is how you come up with this number. That is not as important right now though, okay? So if you don't remember it, it's not such a big deal, but just know that you have to multiply the empirical formula with an integer in order to get the actual ratio. Okay, so the molecular formula is the actual ratio. It doesn't really tell you anything about the structure of the compound, right? It just tells you how many atoms there are for each of the elements. That's all it does. The next thing is the condensed formula. Not the next thing, it's not in any particular order, but a condensed formula is a structure that shows you all of the atoms in there and how they would be bonded, but the bonds are not shown. Okay, so here you will see some word here like the functional groups and all that. So yeah, we kind of tend to write that and we will learn about functional groups in this chapter. So it's there already, and so it's there, but I'm not going to point that out to you right now. I'm just saying that all the atoms are shown in an order in which they would be attached. Now, if you're looking at all of this and you're thinking, what is attached to what now? So here is how you work this out. You focus on the carbon, okay? And again, remember, you don't have to do everything right now. So at this point, we'll just focus on very basic stuff, okay? Because we're going to go into detail. But just in case you're curious about anything, right here, carbon, carbon, carbon. You focus on that. Everything else attached to it is going to be attached to that carbon. Everything after that is going to be attached to this carbon. And that's how it goes. Now, are all these three atoms attached in one location? We don't know yet, and we will learn that, okay? But that's how it is. So what happens is, as you keep learning all of these things, all of these formulas start to make a lot more sense. Like, okay, now I know how the attachment is working, all right? But the main thing I want you to notice is just the atoms in a line. There are no bonds, okay? So you can actually tell a lot by just looking at a condensed structure also. That's what this is. All right. And then let's go on to the next one, which is called the expanded structure. And the expanded structure shows everything. Okay, how everything is bonded. It shows all the atoms. Now, generally it is called the Lewis structure. So which means in Lewis structures, we have to show the lone pair of electrons. But I would say you can skip that if you want to. And actually, I encourage you to skip it, okay? Because I don't want you to focus too much on the lone pair of electrons right now. When it is important, I will tell you, okay? Because we need them later on. But right now, when you're writing formulas, the lone pairs will just distract you, okay? So don't use the lone pairs, just forget it. If you have oxygens, write the oxygen and that's it, move on. So here what you will see is what the connectivity really is like, okay, in this one. So this compound is actually the expanded structure of this one, Okay, that's what it is. All right, and I'm going to flip this around. Okay, so this compound or this oxygen here comes on the right hand side. Right now I'm recording and it's on the left hand side, but technically it should be on the right hand side if you just want to follow this one through. Okay, and it may not matter right now, but later on you might think, oh, she missed that one, you know, and I did kind of, but I don't want to go back and record. So the CH2 OH that you see here is CH2OH. Okay, the CHOH that you see here is CHOH. That is how it's going. So expanded structure is based, of course, on the condensed structure. You're just seeing all the bonds now. Okay, and all the bonds are shown, all the atoms are shown. So you can see the carbons and the hydrogens, oxygens, everything is shown in there. So that is called the expanded structure. Now the expanded structure, as you can see, is quite large, and if you have a large molecule, then it will become even larger, okay, when you start writing it out. So it might take a lot of space in your notebook or wherever you're writing, and that's fine, it can happen, okay, but we don't write expanded structures that much, so we'll talk about that. In any case, then the last thing that we have is the line formula. So the line formula here, you can see, you don't see any carbon here. You also don't see a lot of hydrogens. Okay, you see a few hydrogens, and in these few hydrogens, what you end up seeing is that the hydrogen is attached to an oxygen. Okay, here it is attached to a carbon. Remember this right here, it's this one. Okay, and I will flip this one also on the other side when I flip these two molecules. But this carbon is this one. Okay, so this hydrogen is showing, and I'm going to tell you right now why we show that, but later on it's going to make more sense, and this has to do with the functional group. Okay, so when you have a functional group, you should write that hydrogen. So this hydrogen, the carbon hydrogen, this one is not a functional group, so we don't show the hydrogen, but this hydrogen is attached to oxygen, so we show it. This is a functional group, as we will learn, so we have to write the hydrogen out. Okay, so that is the thing about drawing the line structures. You can eliminate drawing out your carbons for sure. You don't have to show any carbons at all, and the hydrogens also can be omitted when they are connected to carbon if they are not a functional group. Okay, so that is how the line formula works. Now I'm going to tell you one more thing, because I keep talking about it all the time as time goes on, is that carbon and hydrogen are very much organic chemistry. Okay, so there cannot be any organic substance without hydrogen on it or without a halogen on it. Okay, but generally we presume, okay, hydrogen is going to be on it. So what happens is that carbon and hydrogen are considered to be like normal organic, and that's why you didn't even show it here. All the other atoms which are not carbon and hydrogen are called heteroatoms, okay, which means something other than carbon and hydrogen. So heteroatom would be oxygen, nitrogen, halogen, sulfur, all of these would be heteroatoms, okay? So whenever you have a heteroatom in a molecule, you have to show it. So oxygen, you always have to show, nitrogen, sulfur, chlorine, you always have to write those out. They are not invisible. Okay, so I call them invisible carbons and hydrogens because you don't see them. They're there, but you don't see them. Okay, so in the line structure, however, you have to show all the heteroatoms. All right, you don't have to show the other ones. Okay, moving along, because there's so much more to do as we go on. So now that you know all of these different formulas, the empirical, molecular, condensed, line, blah, 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 all of those, what do we use? Do we use all of them, or do we use one or two of them? So really the chemical formulas depend on what you're trying to do. Okay, so what you're trying to study. In different aspects, you learn different things. Okay, so here, for example, when you're using empirical formulas, it's only when you do a structure determination of a compound, or I give you an exercise for some constitutional isomers, which we are going to learn also in this chapter. So, you know, there are very few cases where you actually use the empirical formula. Okay, so we don't use empirical formulas that much in organic. We will, but not so much, okay? And then the expanded structures are used also very rarely, in the sense that you use them only when you're trying to show certain reactions that are going on. Otherwise, they are a pain to draw, okay? Because you can see you have to draw all the carbons and hydrogens and all the atoms in there. So sometimes it takes a long time for us to draw everything out. So generally, expanded structures are used only for certain things. Okay, and sometimes what you do is you only draw out certain parts of the molecule as expanded and the rest of it is shown as something else, okay, because it can get tedious. Condensed structures are used a lot, okay, and we use that only for small molecules. So we are dealing with small molecules and bigger ones also. And sometimes the big ones can also be 6 or 7 carbons. So, you know, those are also small molecules as far as organic chemistry is concerned. So we use condensed structures a lot actually, okay? And so we'll get used to it, and you have to get used to it for organic chemistry. The only thing about the condensed structures, which I find sometimes a little bit hard for everyone, is that they don't show any bonding. Okay, so you have to understand how the bonding is in those condensed structures. So I always recommend that if I give you a condensed structure to do a reaction or something, then you go ahead and draw out, you know, either an expanded structure or you do a line structure for it. Okay, so you can clearly see what the attachment is like, because in condensed structure, that's what you're missing, okay, is the bonds in there. You don't see them. The most common structures that we draw in organic chemistry is the line structures, and I'm going to get you on it, you know, as soon as I can, because line structures is really the best way to learn organic chemistry and the best way to learn things fast and to write things fast. So, you know, because you're missing out a lot of the carbons and hydrogens. You don't have to write those out. So once you don't have to, you have, you know, a lot of, you can do things much faster, okay, with line structures. So I encourage a lot of line structures as we go on. You will see that, but otherwise you have to learn how to draw all the other structures as well, okay, as we go on. Okay, so let's understand these structures a little bit more, okay, before we get into you know, interconverting and whatnot. So the expanded structures here, as you can see, in all of these, I've shown you all the carbons and hydrogens. This formula has nothing to do with the previous ones. This is an entirely different thing because I'm trying to show you something different here. And in this one, you will see that I have written it as a Lewis structure, but I have not shown you any of the lone pairs. And I don't want you to show me the lone pairs as well. I just want you to know they are there, but you don't have to write them. Okay, so just try to save yourself some time and save me the headache also for looking at your lone pair of electrons and making sure they're there. Okay, I just need you to know in your heart that they're there. So there are a few things I want you to understand with these formulas here. Okay, first of all, these are expanded structures. Why? Because you can see all the carbons and hydrogens. Okay, the second thing here, you will see that I've written them in a sort of a zigzag, but you don't have to. Okay, in expanded structure, you can just write like this also in a straight chain. That's also fine. Okay, so I could have written it this way as well, but I just went ahead and wrote in the zigzag form. But I could have written it this way also. This is totally fine. Okay, and when we practice in class, a lot of times this is what we are writing out. Okay, so that's one thing that I want to clarify. The other thing I want to make sure you understand about these bonds is these are all single bonds here between carbon and carbon. Now, I'm not talking about carbon and hydrogen right now because that's going to be a single bond. Hydrogen cannot have a double bond, all right? So not even going to discuss that too much. So between carbon and carbon, between carbon and oxygen, there is a single bond. What does that tell us? It tells us that this bond can be rotated. Okay, single bonds are easily rotated around. They're quite flexible. Okay, so which means what? That, you know, this hydrogen can go up here, this hydrogen can come down here, but because they're both hydrogens, it doesn't matter. Okay, now remember, all these carbons are tetrahedrals. Why? Because they're all sp3. Okay, and that's why I kind of wrote them out this way. Again, you don't have to. Okay, you can write it out straight like this. It's fine. but they are sp3. We can't forget that. Okay, in 3D they will be sp3, which means they're all tetrahedrals. So if they're all tetrahedrals, this is not really the shape. This is really the shape, okay, of what the molecule would look like. Now I want you to kind of imagine an umbrella. Okay, so if you have an umbrella and this is your handle for the umbrella, you can rotate that. You can rotate that umbrella handle, and that's what you're doing here also with all of these bonds. Okay, so imagine each of the tetrahedral as an umbrella with you have, 4 carbons or 4 atoms around that carbon. So this carbon is, you holding that handle, and then you can rotate your umbrella and all of these atoms are going to rotate around. So what does that mean for us, that they're all rotating around? And you will see here, let me erase all the mess that I made. And so you will see here that I have the OH group, okay, going in different directions. That's what I mean by that, okay, is because you're rotating the umbrella because why? You have a single bond, okay, so you can rotate it. And so because it is rotated, it doesn't really matter where you draw the OH group, okay. So here also, if I didn't have it here, I can have it here. It doesn't matter. It's the same thing. So what I'm trying to say, just because it's written on the right hand side or on the top hand side, it doesn't matter. They are still the same compounds. Okay, so you need to understand that if you have a single bond, you will have rotation, and all of these 3 compounds, they're all exactly the same. Okay, what's going to be really important for us as we go through learning how to write these structures is the connectivity, okay, between all of these. And I'm going to be specifying all of that a lot. I didn't write it over here, but we will be dealing a lot with connectivity, how atoms are connected to each other. The bonding, that's the most important thing. You can think of that as the bond also if you want to, but that's the important thing. What is important is how the atoms are connected to each other, and where they are sometimes is not that important, because in this case it's a single bond, so it doesn't matter. So long this carbon has 2 hydrogen and an OH, we're fine. Okay, so carbon has 2 hydrogen and an OH, that's fine. That's how you need to look at this one. Okay, now let's look at the condensed structure. How do we write the condensed structure? So condensed structures are written out by focusing on the carbons, as I said. Now this is the structure for another of the, another organic molecule. Now in this case, I put the OH in the middle, okay, over here. So in the OH is in the middle here, it doesn't matter. And this carbon chain I drew out straight instead of drawing the zigzag, okay, for it. So in this case, how do we start writing the condensed structure? This is the expanded structure. You can see all the carbons and hydrogens. So here are the different variations for this, okay. So how do we start? Focus on the carbon first. Okay, so focus on the carbon. You have 3 carbons over here. So how you would start writing this is carbon, carbon, carbon. Here's how you can start writing. Then you can see what is attached to this carbon. You have 1, 2, 3 hydrogens. So you have the 3 hydrogens. So you write the 3 hydrogens there. What is attached to this carbon? You have an H and then you have an OH. So you have an H and you have an OH. Always write the hydrogen first. Okay, so don't write the OH first, try to write the hydrogen first, because remember, as I said before, carbon and hydrogen are like the backbone of organic chemistry. And then you have the 3rd carbon, and the 3rd carbon has the 3 hydrogens. Now, will you write the 3 hydrogens like this? Like this. Okay, because there are 3 hydrogens, the same atoms. Okay, so that's what we wrote here also. So don't write the 3 hydrogens in a line. All right, write them as H3. So this is one way of writing it. Okay, and then here what I've showed you is another way of writing. There are 2 different ways of, there can be different ways of writing, which is why sometimes organic chemistry can be a little confusing, but that's what I'm here for, okay, to help you with that confusion. So here, this was the simplest way of writing the condensed structure. Now let's look at the other way we wrote this. All I did from this and this is that I put the OH in brackets. Now the OH in brackets helps you to understand that OH is together. How do you know OH is together? Well, right here, it's together. Okay, so that group is together. So you write the OH in brackets if it helps you. If you don't write it, it's not wrong. If you write it, it is not wrong. Okay, and that's why I wrote that option there. If you feel like you need to separate out the groups, you go ahead and do that. You don't write the hydrogen in bracket, by the way. Okay, only anything that has a heteroatom, you write that in bracket, not the hydrogens. These are just some rules that we have. Will I mark you wrong if you write the hydrogen? Initially, probably not, but eventually, yes, I will. Okay, because that's not how it's supposed to be written. Okay, so definitely, try to learn things correctly from the beginning. Okay, now the last one is a little bit more difficult to see, but I'm going to show it to you. Okay, so here, let me erase this. And in this one, the last one, which is CH3CHOH. Here, if you look, these two groups are the same, right? And these are connected to, both of these are connected to this carbon. So that's what I did over here. So CH3, and I have two of those, and then I have the CHOH. Okay? So now if you're thinking, why did I write it before? Could I have written it like this? This is kind of incorrect, okay? Generally, when you have groups like this, okay, when you have two groups attached to the same carbon, then you tend to write them before, not after. Now, in some cases, you will be writing them after also, okay? So for example, if I had, let's say, if I had another OH here, okay, then what I would have done is I would have written CH3, C, and then OH, 2, CH3. Now this is different, right? I cannot write this OH2 before this one. There's no way I can do that, okay? Because technically, whatever is connected to this carbon should come after it, not before it, except for the first carbon. Okay, now if you're thinking, well, this was not the first carbon, I know there are so many arguments here, isn't it? But it's not the first carbon, but these two are the same groups. Okay, and so I have to write them before. I cannot write this. All right, so CH3, 2, CHOH. These are certain rules that we follow, and my job here is to help you understand this. If you don't like this formula, you don't have to write it. Okay, no problem. But I can give you this formula and I can say write the expanded structure, and trust me, if I give you this formula to write the expanded structure, you will end up writing the correct structure. Okay, because if you're looking only at the connectivity, then you cannot go wrong. Okay, so make sure that you go through all of these things, as much as possible, because in the beginning, you're learning, and then, these things can be confusing. All right, let's look at the line structures now. Okay, so line structures should be a little bit easier for us. Generally, it is easy for me. Okay, expanded structures are probably the hardest for me, not because they're hard, just because they're time consuming. Okay, so I prefer to draw line structures, and in this chapter, we're going to do all, so it doesn't matter. We have to practice everything. So first of all, when you draw the line structures, you write them in a zigzag form. Okay, why do we write them in a zigzag form? Is because of the bond angle. Okay, the strange thing about the tetrahedral is that the tetrahedral and a trigonal planar kind of look the same, okay, in a line structure. So this one you cannot tell if it is trigonal planar or tetrahedral, because you cannot see the fourth atom, right? You can only see that there is a chlorine, there is one carbon here and a carbon here, but you cannot see the fourth atom. That's the invisible hydrogen. Because you can't see the fourth, you can't imagine that it is a tetrahedral. Although I would like you to start imagining that's a tetrahedral, because then you will know it's a bond angle of 109. However, when we are drawing a bond angle of 120, we still have the same kind of structure, okay, which is a zigzag. So our zigzags are going to be really important for us because this is the line structure. Okay, now how do we write the line structure? This is kind of the important thing here, is that you draw out all the heteroatoms. You don't draw the carbons, not the hydrogens. So the hydrogens that you draw, as I said, is only the hydrogens that are attached to heteroatoms. Those are the ones that you draw out. All the other ones you don't. So here you can see in the first one, the CH3, CHCl, CH2, CH3. I don't have any of the hydrogens or carbons showing. Okay, how do you start doing this? Okay, the best way to start doing this again is to go ahead and isolate your carbons. I just go through and I underline it. Either you underline it or you number it. 1, 2, 3, 4. So I have 4 carbons here. Now don't go 1, 2, 3, 4. See what you did? 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. So not 1, 2, 3, 4. Sorry, this is way more than 1, 2, 3, 4. Okay, so 1, 2, 3, 4. What you're doing with that 1, 2, 3, 4 is you're drawing 4 bonds. Okay, 1, 2, 3, 4. 1, 2, 3, 4. You're not drawing 4 bonds, you're drawing 4 carbons. Okay, so your counting should be good. Okay, in this case. So when you start counting, initially it's going to be maybe a little difficult, but you know, you'll get used to it. Okay, so 1, 2, 3, 4. How's that? 1, 2, 3, 4. Okay, whenever you finish drawing your carbons, I would suggest you go back and you number. Okay, so that way you know that you have all the correct number of carbons in there, because otherwise it can get really tedious. Okay, and you either end up having one extra carbon or one less carbon. Okay, here what do we have? Here we have 1 carbon, 2 carbon, like this, and then on the first carbon we have 2 carbons. All right, so this 1 carbon, this is 1 carbon, this is 2 carbon. The 2 carbon has the OH on it, so I have to draw that out. Okay, I don't know if you can hear the lawnmower outside, but I'm sorry for that. And then on the first carbon you have the 2 C's, so you draw the 2 like this. No hydrogens, only the C's, right? Only the carbons. So the way you show the carbon is that point. Every point is a carbon. Okay, now if you want, you can draw the dots like I had just drawn, but I mean, you know, a point is a carbon, so you shouldn't have to draw the dots, but in the beginning, if you want to do it, go ahead and do it if it helps you. Okay, all right, again, draw the hydrogen that is attached to a heteroatom. Here I took nitrogen, okay, as a heteroatom. Now nitrogen here is in the middle. Nitrogen has 2 C's connected to it, and then 1 and 2. So 1 and 2 over here, 1 and 2, and then these 2, so 1 carbon and 1 carbon. Okay, that's how it is. So that's the line structure for you. Again, gets a little used to it, right? You have to practice, practice, practice. So we have cyclic compounds also in organic chemistry. In case of cyclic compounds, don't be, afraid of those. That's just fine. So long you know the number of carbons, you just take that. And in this case, you draw the triangle. That's it. 4 carbon in a ring is just going to be a square or a rectangle, as you wish. Okay, just don't make these structures weird looking, you know. And what do I mean by weird looking? I mean that sometimes I get structures with a zigzag like this. This is not a 109-degree bond angle. Okay, your structure should be nice. Sometimes I get things like this. What is this? Okay, so this is not a zigzag. I don't know what this is. Okay, it looks like a mountain range. This also looks like a mountain range, and if I just put this here, there's the sun coming out of the mountain. Anyway, just make sure it's a nice zigzag, okay, that you have going through for your carbon chain. Okay, so see this, you know, all the bond angles and the bond lengths should be equal. Don't do this kind of a thing. Try to make your structures pretty. Okay, so it's not that you don't have the right number of carbons. If you know this was supposed to be your carbon chain, that's fine. but it should look logical also. Okay, this one shows you have different bond lengths, so that doesn't happen. All right, so when I'm saying, you know, draw 4 carbons in a rectangle or a square, well, obviously you're going to draw a proper square and not a rectangle, because this is not a proper bond length. Okay, these two can't be different, so you have to have the same. Okay, bond length everywhere. Okay, let's erase all of that and let's see what else we have here. So now let's talk about, yeah, double bonds and triple bonds. Okay, so here I just shown you double bonds. So for the double bonds here, you have to show the double bond in the line structure. Now, again, there are 3 things, right? We have the expanded structure, the condensed structure, and then the line structure. This one right here is the expanded structure, which shows you all the carbons and hydrogens and the bonding going on. And here you can see that you have to show the double bond. Okay, you can't ignore it. Here also you have to show the double bond. Now, how did you know there was a double bond here? Right? Because see, this is CH2, CH, CH2, and OH. So you are like, how did I know there was a double bond? Now, like some textbooks, they will write the double bond in the condensed structure when technically they should not be. Okay, so some textbooks will show you something like this here, okay, in the middle. And that should not be the case, okay, because in condensed structure, you should not have any bonds at all. So here we're going to get into this in a minute or two, where you can see, and if you don't learn everything right now, it's okay, all right, because you know there's still so much more of chapter 2 that we have to do. But here this carbon doesn't have the proper number of hydrogens to have the 4 bonds. Okay, so if it doesn't have the proper number of hydrogens or atoms to show the 4 bonds, then you have to show the double bond. Okay, so let me show you what I mean by that. Here, if you look at this carbon, technically speaking, if you have a carbon in the middle like this one, see it has 2 hydrogens. This carbon here has 3 hydrogens, right? So this carbon has the 3 hydrogens. This carbon has the 3 hydrogens. This carbon in the middle, if it did not have the double bond, and if it had these 2, the CH3 here and the CH3 here and that, then the 4th bond would be hydrogen if this was not a double bond. Okay, so similarly here, if you draw this out, CH, CH, and then you have the C, and then the H, and then the CH2, CH2, and the OH. So going from here to here is a level of comfort that I would like you to get to. But if you're thinking like, I don't know how to do this, then draw the expanded structure. Or even if you're not comfortable going straight to the line, go ahead and draw the expanded structure. When you see the expanded structure, then you're going to see that these 2 carbons don't have 4 bonds. So if they don't have 4 bonds, the 4th one must be double bond. Okay, similarly, you can add triple bond also if it is lacking even more hydrogens in there. Okay, so what I'm saying that, you know, if one thing doesn't help you, do the other thing. Okay, so if you're not able to visualize, I mean, like when I ask you a question, obviously I'm not going to give you the line structure, right? I'm just going to say that take this structure and draw me the line structure, right? That's what I'm going to say, that draw me the line structure for this. And then if you gave me something without the double bond, you will get it wrong, right? So to make sure that, you know, if you have any kind of structure, you want to make sure 100% that you get it right, draw the expanded structure then. Okay, initially just do it. Okay, so you get the practice and you start feeling comfortable with all of these carbon structures. It may take a little bit time, but that's what practice is for. Okay, so that you don't have to waste time when you're in an exam setting or a quiz setting. Okay, so the last thing I want to talk about just a little bit here is the carbon chain structure. Okay, and the carbon chain structure is, not something that we study as in like the condensed structure, line structure. Carbon chain structures are really just a whole bunch of carbons and hydrogens drawn out when you don't want to draw the line structure or the expanded structure. So sometimes what happens with reactions that you're doing or structures you're trying to show is that you need to be fast and you need to be able to see the connectivity, okay, really fast. So, but you don't have time to draw out the whole expanded structure. So you just go ahead and write the CH3. You don't have to draw out all the hydrogens, okay, on it. Similarly here, you can see that the hydrogens are not drawn out. Now, if this was going to be a proper expanded structure, I would have drawn out the hydrogens, okay, like this. But that's not what I'm trying to do here, okay? I'm just drawing a carbon chain structure where I can see the connectivity between these two, okay? You could have done that with the previous structure that I was drawing also, okay, to see the connectivity of all of those carbons. Again, practice, okay? So you can't do everything at once, but these are all different options. Now, the carbon chain structures, you can draw them, but not for credit, okay? In the sense that I will never ask you to draw a carbon chain structure. If you have to draw a carbon chain structure, you're doing it for your own benefit, in the sense that you're doing it for yourself. You're doing it for when you're writing a reaction, in which case I don't have to grade it. I just have to make sure your structure is correct. Okay, that's it. All right, there's no points for it in the sense, okay, because this is a carbon chain structure is just to help you understand the bonding, is just to help you visualize the structure without having to draw all the hydrogens out. So you can see it's kind of like the expanded structure, but not entirely. Okay, so you can still save some time and still see the connectivity for all the carbons, okay, in there. And if there is any double bond or anything like that, you know, you can see all of those. So it's kind of helpful, but again, usually that's not graded, okay, for most parts. So feel free to use it, okay, for yourself if you need it to help you understand how to draw structures. Okay, so here are some examples, and we'll go through a few of them, because honestly you need a lot of this practice, okay, in the beginning to get used to drawing all these structures out. Okay, so write all the structures for the condensed structure given over here. So which means all the structures, meaning the molecular formula, expanded line, everything here. So the first one, the molecular formula, is an easy one. Okay, all you do is go through all these number of carbons and just add them up. Okay, so 1, 2, 3, 4, 5, 6. You add the carbons, you add all the hydrogens, and you get the molecular formula. And trust me, please do this properly, because so many times I've gotten answers for this and I still get the wrong molecular formula, even though you can see it. Okay, I still get the wrong formula. So please be careful. Okay, expanded structure, again, just go carbon at a time, okay, and then, put them in a proper, you can draw this in a straight chain if you want to, okay? As I said before, you don't have to draw the zigzag. I just did it, but otherwise you can draw it out like this. So carbon number 1, 2, 3, 4, 5, right? This is in bracket, which means this is connected to this one. So which means I have to have 5 carbons in a chain, and then the first one has hydrogen, hydrogen, hydrogen. Second one has a hydrogen and the CH3. Don't write the CH3 like CH3, okay? Don't do that. Go ahead and write out the 3 hydrogens, because expanded means expanded, okay? Everything should be shown. So, and you can see why I find this painful is because you have to draw out all the hydrogens and my writing starts going really bad. Okay, anyhow, so it show all of that out, okay? Number your carbons, that's going to help you. When you draw the line structure, remember 5 carbons in a chain, right? So 5 carbons in a chain. So 1, 2, 3, 4, 5. Okay, the 1, 2, count them really fast. Okay, and then 1, 2, 3, 4, 5. Once you have that on the second one, you know you have to have 1 carbon coming out of it. That's it. Practice, practice. All right, here's another practice. So write all the structures for the line structure given here. So this is the line structure. The first thing, expanded structure, is the best one to start with because I didn't specify what you need to write first. So I would go ahead and write the expanded first so I can clearly see all the carbons and hydrogens in there. You can see the middle carbon does not have any hydrogen, okay, on this one. So once you have the expanded, now everything else is going to be easy, okay, for us. So, you know, C6H14, this is the same as the one before. And the condensed structure, I gave you a couple answers over here. You can do whichever one you prefer. It doesn't matter to me. I will tell you there are some things which are not really appropriate. They're not wrong, but they are also not considered to be very good. But otherwise, you know, I'll survive. For example, let's see this one. The first one, this carbon here, I'm going to focus on this one because I'm going to show you how this one is drawn. You can probably see it, okay, how it is, because right here, this carbon is this one, and it is connected to 3 of the CH3s, so that's what I drew out over here, right? So I wrote that out, and then there's the CH2 and the CH3 and the CH2 and the CH3, right? Easy enough. Okay. Or what you can do is, forget all that. So I'm going to show you the second one now. In the second one, what we have is the CH3. So I just went down the chain. Okay, so carbon number 1, 2, 3, 4. So carbon number 1, this is 2, this is 3, and this is 4. So in the first carbon, CH3, carbon number 2 has 2 CH3s, right? So CH3 and a CH3. And then there is a CH2, CH3, so this is not a problem. So what I was saying about, you know, okay, it's not wrong, but it's not, you know, not quite good thing to do is for, if you were writing CH3C and this CH3, if you write it like this, it's not exactly wrong, but not exactly nice either, okay? So this is the best thing to do because you have 2 of those groups, okay? So just go ahead and put them together. Okay, so this one I wanted to go through with you because I want you to understand in the line structure, one of the hardest thing that's going to be for you in the beginning is to figure out how many hydrogens there are. Okay, so in the previous structure also, I had you draw from the line structure. The first thing I drew out was the expanded structure. Now the expanded structure we drew out, okay, fine. I didn't really explain to you a whole lot. I just said, well, here's the expanded structure, right? That's all I said. But how do you write the expanded structure for something, okay? So one of the most important thing you have to follow in any kind of a structure is the octet rule, okay? Don't forget that you cannot have more than the requisite number or less than the requisite number of bonds unless it follows the rules. Like boron, it can have only 3 bonds, so I understand that, okay? But here, in the case of carbons, it's not going to happen, okay? And not right now. Later on, maybe we'll talk about having less or more bonds, because remember, less or more bonds means that you have a formal charge or you have an exception to the octet rule. Looking at this, I don't see any exceptions because I see only carbons and hydrogens, okay? Well, invisible, but you see them. So how do we know? All right, and how do we know is, let me show you. I mean, there is a whole explanation over here which you can read, okay? But then this is why I'm making the lecture, because I'm going to talk to you right now how to do this a little bit easier, okay? So you can read all this explanation, but focus on what I'm telling you right now. So here you have this structure, okay? Remember, each of these points is a carbon. You can put a dot on it if you want to or not, it's up to you. My question here is, write the number of hydrogens on each carbon. So the way I do this is I look at this carbon and it has 1 bond. It means there are 3 hydrogens. That's what I've written down here also, okay? This carbon has 1 bond, so it must have 3 hydrogens. Why? Because the other 3 bonds are hydrogen. Carbon is supposed to have 4 bonds. So if one of them is attached to a carbon, the other one should be hydrogen. Now for the middle one here, this carbon here, this is attached to 1, 2, 3 carbons. So which means only 1 bond is remaining, and that must be hydrogen then. That's how you go through things. Okay, now that there's a little bit mess, I'm going to go ahead and erase all of this and show you how to do the next one, and hopefully you can do this a little faster. This carbon has 2 bonds coming out of it. It means that the other 2 that are invisible are hydrogens. This carbon has 4 bonds coming out of it. That's it. No more bonds remaining. So which means that carbon has no hydrogens anymore. Okay. And then here, these 3, you can see this is only 1 bond each. So they must have 3 hydrogens each. Okay, so that's how I've shown you over here. Those are the things I've written down in all of these explanations, so you can read it also whenever you get time, but that's how we do it fast. Okay, and I want you to be able to do this fast because there is no point thinking about this for a long time, because carbon only has 4 bonds. How much more would you want to put on there? Okay, now let me just do one quick thing here, okay, before I move on. So let's say there was a double bond here. So if there is a double bond, it means this carbon has 1, 2, 3, 4 bonds. If it has 4 bonds, there are no hydrogens there because it has 4 bonds already. Okay? This carbon has 1, 2, 3 bonds, which means that we'll have then 1 hydrogen if there was a double bond there. Okay, so that's all you have to do is count the bonds, and whatever is remaining is going to be hydrogen, because hydrogen is invisible. All right, and invisible hydrogens give us a lot of problem because we keep forgetting they are there in the beginning. Later on you'll be fine. Okay, but in the beginning, you know, you kind of have to just pay a little bit attention to that. Okay, that's all I have for this one. Okay, make sure you go through all these structures again. This is kind of like the fundamentals of organic.